Okay, today we're going to be looking at the mode and expectation of a geometric progression. So, the mode of all geometric, not progressions, distributions, is equal to 1. Now, if you think about, if we have a geometric progression, think about an example of rolling a dice, and you are looking at the probability of getting a 6. The more times you roll that dice, if you're expecting it to be on the 100th time, the probability of that is going to be very, very low. It's more likely to be one of the first rolls of that dice than some ridiculously large number of events later. So the mode of all geometric progressions is 1, and that is because of the nature of how the common ratio within a geometric progression. So I keep saying progression instead of distribution. So if you remember, p is greater than p1 minus p is greater than p1 minus p squared is greater than, so on and so forth. So the common difference of our geometric progression is less than 1, and hence you're more likely to have your successful event near the beginning of your trials. So the expectation of so remember, expectation of a discrete random variable over a long-term average is given as e of x is mu, which is equal to the sum of x, the probability of x. So if we apply what we know for some geometric progression of probability p, the mean or expectation is equal to 1 over p, the reciprocal of the probability, for some variable which is a geometric progression with probability p. Let's look at some examples. Oh, and just want to I'll remind as we go through them actually. So let us think firstly of nice simple one. Oops, not once. It's not nursery rhyme. 1 in 4 boys. Boxes. Sorry, 1 in 4 boxes of Zingo breakfast cereal contain a free toy. Let the random variable x be the number of boxes that child opens up to and including the one in which they find the first toy. So, if you were given a question like this, it's not told you if it is a geometric distribution or a binomial. We know it's geometric because we're looking for the first successful trial. We're not looking at over so many X number of trials and how many of those are going to be successful. It's that we're looking at the first time we get a success in finding that toy. So we now know that must be a geometric. So firstly, we have to find the mode and expectation of X, and B, interpret the two values in context to the question. So, firstly, part A. Now, it says find the mode. That might, if you see something like that, it makes you think you have to do something. You don't. We know the mode of X is 1, which is true for all geometric distributions. The expectation of X is 1 over P. Now P, success is 1 in 4, so it's just 1 in 4. So it's going to be 1 in 4 and the inverse of it. So the expectation is 4. And now we need to interpret these two values. Now it says in the context, so if you're asked for something that you've got to interpret a result in the context of the question, you need to actually refer to what the question is telling you, the setting of which the question is in. So a child is most likely to find their first toy in the first box they open. But on average, the child will find their toy in the fourth box. Okay, let's look at another one. The variable X follows a geometric distribution given that E of X equals 3.5. Find P where X is greater than 6. So we know that E of X is equal to 1 over P. So, and we know that 1 over P is equal to 7 over 2 because the expectation is 3 over 2. I will just put that into improper fraction. So P is equal to 2 over 7 taken inverse. Now, we're going to need this is P, we're going to need to find Q. So remember, that's the probability of a success. Q is the probability of not having a success, so that's going to be 1 minus P. So Q is going to be 1 minus 2 over 7, which is 5 over 7. Now, we're going to use the fact that for some probability where x is greater than r, it's equal to q to the power r. So we've got, in this situation, q is going to be 6, so it's going to be q to the power 6. We know what q is, so it's 5 over 7 to the power 6, and that gives us 0.133. Let's do one more. Given that x is a geometric distribution and with probability p, and that the probability that x is less than or equal to 3 is equal to 819 over 1331. Find the probability that x is over 3 and the probability of 1 that p falls between 1 and for 1 x between 1 and 3, less than or equal to 3. So we know it's less than or equal to 3 is this, but then all other values for the probability are x greater than 3. So the probability that x is greater than 3, it must be equal to 1 minus the probability that when x is less than or equal to 3. So that's 1 minus 819 over 1331, and that gives us 512 over 1331. Now, we want this, to find this probability. So, the probability, so that we're looking at the values for x, which are not 1, so x is going to be 2 or equal to 3. So if we think of when the probability for when x is less than or equal to 3, all other probabilities are going to be 1 minus q cubed, and I'll show you why. Let's look at our two. So we need our two results here. We know when the probability when x is less than or equal to r, we've got 1 minus q to the power r. And we know the probability when x is greater than r is equal to qr. So we've got this here, which tells us the probability when x is less than or equal to 3, it must be 1 minus, q cubed. Now, by using this, we're able to find out the value, the probability is not a success. So we've got 819 over 1331, 1 minus q cubed. So q cubed is going to be 1 minus all of this, and then we can work out this, take the cube root, and we'll get the value of q as 8 over 11. So that then leads us to the probability of a success is going to be 1 minus this, so that's 3 over 11. Now, we know, I'll write that next bit up here, so we want the probability between when x is between 1 and 3 or equal to 3. So that must be the same as when the probability is x is either equal to or less than 3 minus the probability when x equals 1. So we're given this is just 819 over 1331, and the probability when x equals 1 is just 3 over 11, and that gives us 456 over 1331. So hope that helps.